Algebra 1, Lesson 4, Exponents. In this lesson, we will start talking about exponents. An exponential expression is usually stated in the form a to the n, where a is what we call the base. The base is the number that we will be performing the exponential operation on. The number n is the exponent, which tells us how many times we need to multiply the constant with itself. Or maybe more intuitively speaking, how many times we need to multiply the constant with the number 1. A basic example of how we would evaluate an exponential expression is with 2 to the power of 2, or 2 squared. This could be evaluated as 2 times 2, or it could be evaluated as 1 times 2 times 2. Both of these methods of evaluation are correct, and the solution equals 4. Here is another example. Evaluate 3 to the power of 3, or 3 cubed. First, we identify the constant, which is also called the base. The base in this expression is 3. Now we look at the exponent, which is the small subscript on the upper right. That number is also 3. What this means is that we multiply the number 3 by itself 3 times. So, 3 times 3 times 3 equals 27. So, 27 is our final answer. We can also evaluate exponential expressions with negative exponents. Like with positive and negative integers, positive and negative exponents also have their own inverse relationship. When we evaluate an integer raised to a positive exponent, we use the integer as our base and multiply it however many times the exponent specifies. However, when there is a negative exponent, you must first change the base integer into its reciprocal and then multiply itself, however many times the exponent tells you to. Here's an example. Evaluate 7 to the minus 2. First, we change the integer 7 into its reciprocal. Since 7 is the same as 7 over 1, we get the reciprocal by flipping the numerator and denominator. So the reciprocal would be 1/7. Then we multiply 1/7 by itself twice, so now we have 1/7 times 1/7, which equals 1 over 49, and that is our correct answer. Other basic rules you need to know about exponents. 1. Watch out for exponential expressions with negative integers as bases. For example, -3 squared is not 9. The negative sign negates the value of +3 squared, which is 9. So, -3 squared is the same as -3 times 3, which equals -9. 2. Any integer raised to the power of 1 is always that integer in most cases. For example, 5 to the first power is still 5. 3. Any integer raised to the power of 0 is always 1. So, whether the integer is 6 to the 0 power, 10 to the 0 power, or even 200 to the 0 power, the solution will always be 1. Finally, any real number raised to an even exponent will always be positive. Any number raised to an odd exponent may be negative. For example, 4 cubed is 64, while -4 cubed is -64. So that's it for the basics of exponents. In future lessons, we will expand on our knowledge of exponents and how they can relate to another type of mathematical expression called the radical. We will also go over some formulas that will be important for you to know to not only do well in this course, but in higher level math and science courses as well. See you in the next lesson.